Hello students, today we see some more problems about buffer solutions. See the first one today. So by adding 6 grams of sodium hydroxide, we know that sodium hydroxide is a strong acid to a 500 milliliter of buffer solution. So it may be acidic buffer or basic buffer, whatever. So to that buffer solution, 500 milliliter of a buffer solution, 6 grams of sodium hydroxide is added. So then its pH value changes from 3.8 to 4.2. So find the buffer capacity. We know that buffer solution means actually strong acids, some amounts of strong acid, strong base add చేస్తే దాంట్లో pH value no change అవ్వాలి. But after some time, very few amounts add చేస్తేనే that pH value no change. But after adding some ఒక specific amount తర్వాత extra add చేస్తే there will be change in the pH. Different pH, different buffer solutions are having different capacities. Right? Different buffer solutions ki pH value change చేయాలంటే different amounts of acids కానీ bases కానీ add చేయాలి. Okay. So already we do have a direct formula for buffer capacity, that is 5. Buffer capacity 5 is equal to the number of moles of acid or base added to buffer by pH change into volume in liters. Okay, this is the formula. Say the equation 1. Now what is the number of moles of acid or base? Here it is given base. So the number of moles of sodium hydroxide. So weight by molecular weight. Okay, what is the weight? Weight of the compound is given 6. Its molecular weight, we know that it's 40. Okay, just write it like that only. Next, what is the pH change? What is the pH change? pH change equal to 3.8 to 4.2. Means what is the difference? You have to know the difference, means higher value minus lower value 0.4. So what is the volume? Volume you must calculate in the liters. So 500 milliliters means 500 into 10 power minus 3. So it becomes so 10 power 3 means it's become 50 liters. Okay, sorry. So 10 power minus 3, not 2. So minus 3 we will get so 0.5 liters. Now substitute all these values in equation 1. The buffer capacity 5 is equal to number of moles added, weight by molecular weight, 6 grams is added. Okay, next, sorry, what is the pH change? 0.4. What is the value? 0.5. So here we get so on this calculation, this is by 10, make it by 10. So so on the overall calculation we get again so finally we will get 0.75. 0.75 moles per liter. 0.75 moles per liter. So this is the buffer capacity. Means what is 0.75 means per liter, and per liter అంటే ఈ బఫర్ సొల్యూషన్ 1 లీటర్ సొల్యూషన్ తీసుకుంటే దాని pH వాల్యూని 1 యూనిట్ చేంజ్ చేయడానికి 1 యూనిట్ చేంజ్ మీన్స్ ఇట్ మే బి ఇంక్రీజ్ అవ్వచ్చు, ఇట్ మే బి డిక్రీజ్ అవ్వచ్చు. సో 1 యూనిట్ pH వాల్యూ చేంజ్ చేయడానికి 1 లీటర్ ఆఫ్ దట్ బఫర్కి ఎన్ని మోల్స్ ఆఫ్ సోడియం హైడ్రాక్సైడ్ యాడ్ చేయాలంటే 0.75 moles of sodium hydroxide should be added. Okay. Next, see one more problem relating to buffer capacity. So that is sweat. Okay, see one more problem on buffer capacity. Okay, see he is given the pH of a 1 liter buffer solution changed from 10.8 to 11.2. Again there is a difference of 0.4 by adding 20 grams of caustic soda. Caustic soda, again this is sodium hydroxide. So calculate the buffer capacity. So direct question, what is the formula of buffer capacity? Phi is equal to number of moles. Number of moles of acid or base added to buffer by change in pH into volume in liters. Okay, so here we direct substitute the values. So a number of moles of acid or base. So here number of moles means it is given 20 grams. Number of moles means it's weight by molecular weight. Okay, next. What is the change in pH? Change in the pH 11.2, 10.8. So what is the change? Again 0.4. What is the volume? This is exactly given 1 liter. Directly given in terms of liters. Okay, 1 by 2. The phi is equal to, sorry. So 0.5 by 1 by 2 we can write 0.5 by 0.4. So finally we will get 1.25. Is it correct? So for the cancel. So its buffer capacity is 1.25. Okay, see the question number 3. So here the pKb, P4Kb direct given for a weak base, NH4OH is a weak base is 4.8. I have to find the pH of the mixture of 25 milliliter of 2m NH4Cl. Ammonium chloride is a salt, and 50 ml of 0.1 m NH4OH. Means what you understood. So here, so NH4OH. NH4OH is a weak base. And what about NH4Cl? NH4Cl is it's a salt. It's a salt of NH4OH with a strong acid HCl. So means this mixture will, therefore it is a basic buffer. Weak base combined with a salt with a strong acid. So it will be treated, this mixture will be treated as a basic buffer. Means we have to identify the given problem. So the solution is a normal acid base mixture or any other single compound or any buffer solution. Okay. So therefore, for basic buffer, we always calculate the pOH. pKb plus log of salt concentration by base concentration. So the pOH is equal to pKb is direct given as 4.8 plus log of salt concentration. So what is the salt? Here ammonium chloride 2m 25 milliliter. Actually we have to calculate that salt concentration given as 2m. మనం మిల్లీ ఈక్వలెన్స్ క్యాలిక్యులేట్ చేస్తాం కాబట్టి just 25 into 2 చేస్తాం. But actually we need to get its concentration in total volume. So total volume అయినప్పుడు its concentration become 25 into 2 by 50. Sorry, not 50. That what is the total volume? This is 50 ml. This is 25 ml by 75 ml. So what is the base? Base concentration is also given 0.1 m. We used to calculate the milli equivalents, so 50 into 0.1 m. But we have to calculate the final cons after mixing. We have to calculate the concentration. So 50 ml into 0.1 by what is the total value? 75. Okay, already we know that this 75 get cancelled, but the correct procedure is uh, first write the values. Okay, so we know that they will exactly cancel. So next, so remaining this 1 by 10. So value becomes how much? So we can write it as log 10. Log 10 we know that log 1. So log 10 equal to 1. So it becomes 5.8. But actually we have to calculate the pH. pH equal 14 minus 5.8. So how much we will get? So it becomes 8.2 something. Okay. So the pH of that basic buffer solution is 8.2, or I think in the options it is given as 8. Okay, see one more question in buffer solutions. So the calculate the pH of a buffer solution, directly it is given as a buffer solution which is prepared by mixing 0.08 m acetic acid and 0.04 m potassium acetate at 25 degrees Celsius. There is no value means given, so already it is a buffer solution, so the final value is not particularly given. There is no need to find it. 25 degrees Celsius. pK is also given. Find the pH. So it is exactly given as a buffer. So acetic acid is a weak acid. Therefore, weak acid given means it is an acidic buffer. So for acidic buffer, we calculate pH. pH equal what's the formula? pKa plus log salt concentration by weak acid concentration. So the pH equal pK is given directly, that is 4.74 log of what is the salt. We have to identify which is salt in the given mixture, which is salt, which is weak acid. Means you need to perfect about acids, bases, salts. Already we given the list of acids, bases and salts. So there is a log. Salt is how much? CHCO. Okay, 0.04 m in moles per liter. So it is also given 0.0 m, that is 0.08 m, that's also moles per liter. So we get 1 by 2. Here log of 1 by 2. So here the log 1 by 2, it can be written as, we know that log A by B. So this is nothing but log A by B. So log A by B means nothing but log A minus log B. So the pH is equal to 4.74 plus log A minus log B. So pH equal 4.74 plus log 1 0 minus what is the value of log 2. We have to remember the values of this logarithm values at least up to 10. 0.3010 approximately. So pH equals we'll get approximately 4.4. Okay, this is the pH of a given acidic buffer. So it is compulsory to remember the pH value up to 10 at least. Okay. We'll see the next one. So the P power K, so the pK of HCl. So we know that HCl is a weak acid. Hydrogen cyanide is a weak acid. 9.3 is given. So the pH of the solution prepared by mixing 2.5 moles of the weak acid and 0.25 moles of KCN. So KCN means what is the relation these two means? And HCN, the CN minus, it is having its conjugate base, and one more, the KCN is nothing but it is a salt of HCN, with a strong acid HCl, KOH. Already it is acid, it must form a salt with a strong base. The strong base potassium hydroxide becomes a KCN. So therefore we can say the mixture is an acidic buffer. So we got it is an acidic buffer. That's why we have to use the formula. The pH is equal to P power K log of salt concentration by weak acid concentration. So the pH equal P power K directly given 9.3 plus log of what is the salt? What is the salt here? So KCl, it is directly given in terms of moles per liter, moles 0.25 present in 500 milliliters. So it is also present in 500 milliliters. So they will cancel, no need to write again. So 2.5. So just on the calculation is here important. So here 0.25 become 1 by 4. Okay, 1 by 4 becomes 10. Okay, so pH is equal to 9.3 plus log. So on this calculation here it can be written as 25 × 10⁻⁻², and it can be written as 9 × 10⁻⁻1. Okay, so minus 1 will become 10⁻⁻1 only. Log, this is how much? It is just 1 by 10. Okay, we can write that just 10⁻⁻1. So the pH value becomes 9.3 minus 1 log 10. We know the log 10 value is 1. So the finally pH is equal 9.3 minus 1. The final pH is 8.3. Okay, here the pH is 8.3. So even it is having the 8.3 value, it will be treated as an acidic buffer only, because for normal acids, for normal bases, the pH value for acids is compulsory below 7. For bases, pH equal to always greater than 7. But it is not perfectly works in a buffer solution, because in buffer solution pH value based on the ratio of that acid, weak acid and salt ratio. So that's why it is for acidic buffer it is not like that, that always its pH value will be less than 7. For basic buffer it is not equal to always greater than 7. So here see it is an acidic buffer, but it is having pH 8.3. Okay, see one more question. So that is a buffer is prepared, directly given as a buffer solution is prepared by mixing this 10 milliliter of acetic acid. We know it is a weak acid 0.1 m, and 20 milliliter 0.5 m of sodium acetate. Actually this is the salt of this weak acid with strong base NaOH, means this is the salt. So then again its solution is diluted to 100 ml, diluted to 100 milliliters. Means what is the initial volume? This is 10 ml, this is 20 ml. The total mixture becomes just 30 milliliter. But after adding 70 milliliter of water, they made it to 100 milliliter. So find the pH of final solution. So actually We know in the conceptual questions or in the concept, in the main points, we explained that the buffer solution's pH does not altered, does not affected by the dilution, because the dilution, the overall volume of the solution is increasing. Means the volume of the salt solution and also volume of the weak acid or weak base solutions are combined we are taking. So the ratio covered automatically it will be cancelled. Means there is no effect of a pH of buffer solutions on dilution. Mean just it is given just for the confusing, so no need to consider it. So it is an acidic buffer we got. So the pK is given 4.76. The salt, we have to identify the salt. That's only the important thing in these problems. Total value by 100, no need to write it. This one becomes a log 10. So the final pH we will get how much? So 4.76. This right here 2. So already given how much the salt concentration? 0.5 into 20. Okay, 0.1 into 10. So here we will get the value 5.76. Yes, finally we got how much the pH equal to. We know the log 10 is equal to 1. .76. Okay, we see one more problem. See, the question is an acidic buffer. So all it is given, an acidic buffer contains .06 m salt. It is not mentioned that is given as a salt, and 0.03 m, sorry, 0.02 m weak acid, and acid dissociation constant of acid is 10 power minus 4. So find the pH of buffer. Find the pH of that buffer solution. Well, it is given acidic buffer, so the pH equal to pKa plus. You have to write the formula for every problem. It is compulsory. So pK is given how much? Actually, it is given Ka. So Ka, for pKa, how you calculate? Minus log K. So plus log. What is the salt? What is the molarity of the salt? Moles per liter. So 0.06. Value is not at all given. Just think it as a 1 more. Molarity given means moles per liter. So it becomes a 4 log 10. this is log 3. So 84 log plus, so log 3, I think approximately 0.447 we have log 3 value. I think it's 47 or something is there. So I will check the log 3 value. Log 3 value is not 0.447. So actually it was 477. Okay. So finally pH equal will get to 4.477. I think in the option it was given as 4.48. It's okay. Okay. So this is the pH of this buffer solution. So tomorrow we done a very simple problems. This direct acid buffer pH, basic buffer pH calculations, and some buffer capacity problems. So tomorrow we see some difficulty problems belong to buffer solutions pH. Okay, so try to practice the problems at least 2 to 3 times.